So yesterday we talked about permutations, which is where the order was important. Today we're going to talk about combinations, which is where a selection of objects in which order is not important. For instance, we are doing a drawing for 3 identical prizes, right? It doesn't matter whether I say it's Sam, Sarah, and Sally, or Sally, Sarah, Sam. It's the same group of 3 people. If the prizes were different, we'd use permutations because the order would matter. So for example 1, it says count the combinations of 2 letters from the list A, B, C, or D. So let's just say that these represent people's names like Abby, Betty, Chris, and Dan. I don't know, okay? And we're putting them in pairs. So if I say, I don't even remember their names now, A and B, that's the same as saying B, A, right? It's the same group of 2. So I can get rid of that. It's not a unique combination. Or saying AC is the same as CA. Or CB is the same as BC. Where is BC? Oh, did I miss one on here? Oh, this should be C, but we're going to cross it off anyway. Or saying AD is the same as DA. Saying CD is the same as DC. DB is the same as BD. Did I get them all? We'll find out in just a second. Let's see. Oh, we did. Okay, so we have 6 actual unique combinations of letters. Okay, but it's super annoying to have to write out a whole sample space and then cross out duplicates. So what we can do is use combination notation, which is where you do the permutation divided by the factorial of how many choices you're making. So for example, okay, we're going to set it up just like yesterday, where this would be 4C2. We're making combinations of 2. So the permutation, just like yesterday, is 4 times 3, right? That's what goes on top. But then on the bottom, because I'm making 2 choices, I divide by the factorial of 2. So 4 times 3 is 12, over 2 is 6, which is what we got up here. Okay, so it says you order a sandwich at a restaurant, and you get to choose 2 side dishes from a list of 8. How many combinations are possible? Okay, so saying salad and breadsticks is the same as saying breadsticks and salad. I don't know why you would get breadsticks with a sandwich, but whatever. Okay, so it's a combination problem because the order that I'm picking my sides in doesn't matter. I'm going to get the same 2 side dishes on my plate. So it's 8C2. So 8 times 7, the permutation, right, divided by the factorial of 2, 2 times 1. 8 times 7 is 56, over 2 is 28, right? You could have even said 2 goes into 8 4 times 7 is 28. Look at number 4. You sing in a choir after school. The director will choose at random 2 songs out of 5 for the choir to learn to sing. How many combinations of songs can the director choose? Okay, so we have 5 to choose from. We're picking 2. It doesn't matter whether we pick God Bless America and then Jesus Loves Me, or Jesus Loves Me and then God Bless America. It's the same 2 songs. So 5C2 would be 5. I should have put an example that wasn't always 2. 2 times 1. 2 goes into 4 2 times. 5 times 2 is 10. So now, what is the probability that the director chooses your 2 favorite songs? So that would be 1 out of 10, right? 1 combination of 2 is your favorite. There's 10 unique combinations of songs, so the probability that the director picks your 2 favorites would be 1 out of 10. Your teacher, we're going to make this 3 because every single one I've done 2. Let's actually do, oh my word, also that should be debate, not debate. Let's say 4, okay? Your teacher randomly chooses 4 out of 18 students to give an impromptu debate on the freedom of the press and high school newspapers. What is the probability that the teacher chooses you and your 3 best friends? Because I'm doing groups of 4. Okay, so let's look at it. So that would be 18C4. So 18 times 17 times 16 times 15, because I'm starting on 18, I'm making 4 choices. and we're dividing it by 4 times 3 times 2 times 1, the factorial of 4. So what we can do is we can reduce things. So like 4 goes into 16 4 times. 3 goes into 15 5 times. I can say 2 goes into 18 9 times. So now my numbers are smaller, and I'm going to multiply, 9 times 17 times 4 times 5, and I get 3,060. I'm going to double check my math real quick. Yes. Okay, so there are 3,060 unique groups of 4 just out of 18 people. So what are the chances that it's going to be you and your 3 best friends? 1 out of 3,060. Okay, so when Miss Boise and I are putting you in groups, there's like 18 boys. You're like, oh, I just want it to be me and these 3 other guys. The chances of that happening are 1 in 3,060.